Hey guys, this is lesson 6-9, multiplication of decimals. You can see here that we're going to learn a couple different strategies for solving decimal multiplication. We're also going to understand the place value system, and we're going to perform operations with multi-digit whole numbers and with decimals to the hundredths. To start off, I want to take a look. It says explain how the placement of the decimal point in the first factor will change and then evaluate it. So take a look here. I've got the answers right here to the side. 4 times 10 to the second power. If you recall, 10 to the second power is the same thing as 100. So here we are saying 4 times 100, and that's where you would get 400. You can also remember that the decimal place moves 2 spots over to the right, and it's the opposite with the division. Division, you're actually going to move the decimal to the left. Your number is going to get smaller because you're dividing it. So you have 900 divided by 10 to the second, or 900 divided by 100, and you would get 9. Okay, so your decimal would be here, and you would go 2 spots, giving you the answer of 9. So if you haven't yet, you should probably get out your math journal at this point in the video to follow along with us. You'll want to turn to page 219, and you're going to look at the question at the top of that page. Go ahead and you should have completed this already. It says some strategies for solving that problem. You could use repeated addition to solve by adding 1.2 8 times. So as you can see, 1.2 plus 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 1.2, you'll get 9.6. Or you could also multiply the whole number part of the decimal, which is 1 by 8 for a product of 8, and then add on the 0.2 or the 2 tenths. You're going to add that 8 times, and that gets a 1 6 tenths. Then you add that 8 and this 1 6 tenths, and you get a total of 9 6 tenths. So here we have Tori has 8 blocks. Each block is 1.2 centimeters high. If Tori stacks the blocks, what will the height of the stack be? And this is your problem at the top of 219. And it says, how would you make an estimate for 1.2 times 8? I want you to think about that for a second. Hopefully you would said that it would be like rounding 1.2 to 1 times 8, and you know your answer, your estimate would be around 8, but we know it would be a little bit higher because of that 0.2 there. And you can see that the actual answer is 9.6. And so does 9.6 make sense with our estimate? Yes, it does, because 9.6 is very close to 8. It's very close to 8. It's in that same range that we would want. So on this slide, we see that we've got 3 different multiplication problems. We've got 1 2 tenths times 8 tenths. We have 1 2 tenths times 8, and we have 12 times 8. So I'd like you to use your calculators to solve this problem. Well, each of these problems, because we have 3 here. You can find your calculator on your Chromebook. You can use it on an iPad, iPhone, a tablet, or if you have an actual calculator similar to the one that's pictured here, you can solve those. I want you to think about the pattern that you might see. What do you notice about all the factors in all 3 problems? I hope that you found that 12 times 8 was 96. And as you look up this table, so we start here, and if we move up, 1.2 times 8 would be 9.6, which we found earlier. And 1.2 times 0.8 would be 0.96. And I hope you found that the digits are the same in all 3 problems. It's just their value based on where that decimal place lies in your calculator. Do you think this pattern is true for all multiplication problems with factors that have the same digits in the same order? Well, to test the pattern, I want you to test it by writing down 3 multiplication problems with factors that have the same digits in the same order, but with the decimal point in different places, just like you saw earlier. Test out that pattern and see what you get. So here's another example, and this is the process in which you would want to do as we move on with our work in these pages in the journal. Example would be 6.8 or 6 and 8/10 times 2 and 1/10. Your first step you want to do is make an estimate. Then you want to multiply if the factors were whole numbers. So for this one, it'd be like 68 times 21. Then use that estimate to place your decimal point. And so we know that we would take 68 times 21 and you get 1,428. But we know that if we estimate, we could do 7 times 2, which would be 14. So if I place my decimal in the correct place, I would see that 6.8 times 2.1 should be 14.28. Remember, it's important to estimate when using this strategy because without an estimate, you will not know where to place the decimal point after you've multiplied the factors. So if you haven't yet, turn to page 219. And I know I have the answers on here already for you, and that's okay because this is a lesson that we're learning with. We're going through it together. It says, again for you, it says to step 1, make an estimate. Step 2, multiply as if the factors were whole numbers. And then step 3, use your estimate to place the decimal point in the product. So you can see here they had 76 and 1/10 times 9 and 6/10. Their sample of estimation was 75 times 10, which is 750. Once they actually multiplied 761 times 96, they got 73,056, but they knew with their estimate it needed to be in the hundreds, so close to 750. Therefore, they put their decimal point right there with an answer of 730 and 56 hundredths. Number 2, on page 219, we see 189 and 6/10 times 1 and 75 hundredths. An example of an estimate would be rounding it to 200 times 2, which is 400. You could also do 190 times 2. It still shows you that it should be in the hundreds range for your answer, for your final answer. So once you take these numbers and you remove the decimal, you will have a thousands. So 1,896 times 175. And it's not going to give you an answer of 3,318. What you're actually going to see here is that you're going to take 189 and turn it into 1,896 times 175. And that is actually going to give you a very large number. So 1,896 times 175 is going to equal 331,800. So when I see that answer there, and I'm looking at this part, let me make that larger for you. I see this number, this answer. I know that my answer needs to be in the hundreds. So I look at this and I see, well, where would my decimal go? Well, I know my decimal could go right here to be close to what my estimate was. And that's what they did here. All they didn't do was put the 2 zeros after the 8. And I can put those on there for you. As you can see, I've done there. So that's actually what the answer would be if they kept all the digits. So you want to make sure that you pay attention to how big your number is. And even though it's got the zeros at the end, those still counted for our final answer and putting where our decimal goes. And then number 3, 5.6 times 0.8 or 5 and 6/10 times 8/10. We can do an estimate of 6 times 1 equals 6. And you see that they got an answer of 4 and 48 hundredths. Reason is they took 56 times 8 and they got 400. 48, and they know that their answer needed to be in the ones place or close to 6, and 4.48 is the closest with that decimal point to getting to 6. You've got different options when you are writing this. This is what our actual answer was without the decimals. You could do 4.48, you could do 44.8, or you could do 448, and then if you put it at the beginning, it'd be 0.448. And so we know these are the options we have, and we know this one right here is the one closest to 6 when listing out all of our options. So 4.48 based on our estimate. Now, looking at a question like this, these numbers are both below 0. We have 73 thousandths times 2 hundredths. And so I want to ask yourself, would you expect the product to be greater than or less than 73 thousandths? Why do you think that? Well, I hope you remember that in the last problems, we ignored the decimal point and we multiplied both the factors as if they were whole numbers. So if we were doing that, we would start off with turning 73 thousandths into 73. And we see that it moved 1, 2, 3 place values in the right direction. Then we changed 2 hundredths into 2, and it moved 2 spots to become 2. Okay, so here's another image of showing how that decimal point moved. And you can see that actually you're taking 73 hundredths times 10 to the third, or 73 thousandths times 10 to the third, or meaning 73 thousandths times 1,000, and 2 hundredths times 100 to turn those into whole digits. And so you can see here 73 times 2 is 146. Remember, you didn't estimate the answer in this problem. You can't use estimate to determine the placement of the decimal point. Okay, so on this one, we couldn't do that. We did not do an estimate. So instead, we have to undo the changes we made when we changed the factors to the whole numbers. So when we changed 73 thousandths to 73, we multiplied by 10 to the third. So how could we undo that? What's the opposite of multiplying? And the same thing, when we changed 2 hundredths to 2, we multiplied by 10 to the second power. How can we undo that? So, summarizing our steps, remember, multiplying both factors by a power of 10 to make them whole numbers. Keep track of both the powers of 10 or the total numbers of spaces, decimals, points shifted in both factors. So you multiplied by the whole number. Then you undo the multiplication by powers of 10. Divide the product by both the powers of 10 and shift the decimal point to the left. The total number of places is shifted when changing the factors. So here you'll see we have our 146, and this time we have 10 to the fifth. That is because up here we saw we had a 10 to the third and a 10 to the second. So 3 plus 2 is 5. So we see 1, 2, 3, 4, 5. We need to input 2 zeros. So we get an answer of 0.00146. So I want you to try this on your own. 12.6 times 2.75. And I want you to use those steps that we talked about earlier in this video. Do an estimate. Change them to whole numbers. And then place your decimal point based on your estimate. You can do that for this one. After you have solved it, you can check with a calculator. And you should have gotten the answer of 1 second. If we take 12.6 times 2.75, 34 and 65 hundredths. And our estimate could be 13 times 3, which when you do 13 times 3, that's 39. So our answer would be correct with that. Your job now is to finish page 220. So if you take a look, page 1, or not page 1, page 220, number 1, they have the steps at the top for you. Solve problems 1 through 3 using the following method. Step 1, multiply both factors by a power of 10 to make them whole numbers. Step 2, multiply the whole numbers. Step 3, undo the multiplication by powers of 10 by dividing. Okay. So again, multiplying factors by a power of 10 to make them whole. Step 2, multiply the whole numbers. Step 3, undo that multiplication by powers of 10 by dividing by the product by the same powers of 10. So for this first one, we see we have 76 and 1/10 times 9 and 6/10. You would turn 76 and 1/10 into 761. And I want you to think about how many powers of 10 do you multiply that by to get that whole number. 9.6 times 10 to what power will give you 96? I want you to think about that. Fill those in your math journal. I hope that you said 1 for each of those to turn them into whole numbers. It takes 76.1 times 10 to the first power to turn that into a whole number. Same thing for 9 and 6/10. Takes 1 power of 10 to turn that into the whole number. So your answer of the whole number problem is 73,056. But if you were to do an estimate for this and you were to do what they said, where you see we have 2 powers of 10, that means we're going to go back 2 places. We would put our decimal right there. That would give us 730 and 56 hundredths. Number 2, 189 and 6/10 times 1 and 75 hundredths. Same thing as the last problem. I want you to think, what power of 10 turns 189 and 6/10 into a whole number? How many powers of 10 does it take to turn 1 and 75 hundredths into a whole number? What would you get if you multiply 1,896 times 175? I hope that you got this answers in your book. We would see that it would take a power of 10, 1 power of 10 to turn that into a whole number, and a power of 2 to turn 1 and 75 hundredths into. So then you'll see 331,800. And we see that if we turn that into a decimal, that's 331 and 8/10. Notice again, just like earlier, they didn't put the zeros on the end. And that's okay. We don't have to. But for now, while we're learning, I would continue putting those there. And our last problem, 5 and 6/10 times 0 and 8/10. I hope that you were able to get 5 and 6/10 times 10 to the first power to equal 56, and 8/10 times 10 to the first power to get 8. If you take 56 times 8, you get 448. If you use the powers of 10, 1, 1, so 1, 2, we see that we can move the decimal back 1, 2 spots, gives us 4 and 48 hundredths. That is the end of today's lesson. I hope that you were able to follow along. I hope remember that you can pause anytime you need to, and you can rewatch this as many times as you need to in order to understand.